that is always equal to 2 pi r. These two things are the constant, and the only variable thing is r. If the r increases, the circumference increases, and the vice versa. And the other thing is the area, and the area really depends upon the that is, we call it pi r square, right?
Okay.
um so, my one question, like, that's the food for thought, actually. Mm, what is radius?
It's the distance from any area on the circumference to the middle.
Perfect. Can we make it like this? This one here. Is this the radius, the yellow one?
No,
Yeah, it is always the center. Good. The other thing is, what is pi? What is pi?
it's like a irrational number
Mm,
used to calculate circles.
yeah. It is the ratio between the circumference and the diameter of the circle, right? Okay.
Okay.
Okay. So today we're gonna talk about the radians, but we need to know first the angles. How many angles are there in a complete circle?
Um,
360, right?
uh, yeah.
Uh, it was like skipped out of your mind, or you did not know it?
No, I just didn't understand the question.
Oh, okay. The total number of degrees in a complete revolution of a circle is 260. Um, One way, maybe there is a logic here. There are two types of the calendar. One calendar says the total number of days in a year are 355, and the other one says it is 365. So it might be the average value. That's why we divided it into 360 degrees, not in 400. Maybe, but it is not a mathematical answer. So let's see what is a radian. So radian is related to something radius. Let's see here. So if the definition says, if the if we make an arc length here that equals to the radius, like this blue line and this black line, they are equal in length, like this, and this one here, the angle subtended at the center when the arc length, that's the part of the circumference, and the radius, they are equal in length, the angle subtended here, that we call it the radian. So let's make a diagram here. So this is a circle. It is having a radius, let's say it is 1 meter. And if we make a arc here, that is also 1 meter, this angle would be called as 1 radian. And if we do the same thing, let's say it's another 1 meter here, 1 meter. So the second angle would be called as, like, we can call it another 1 radian, or total 2 radians. So let's see through the animations here. So what do you need to watch here? You need to tell me how many radians are there. So first one is the blue one here, the first radian. The second radian is here, the yellowish one. Third, fourth, fifth, and sixth. So how many radians are there in a circle total?
6.
Plus something here. 6 complete radians, but something is missing here. It is not the complete, but more than 6 and less than 7. So we will counter this part here in our next calculations, but roughly we can call it 6 radians.
Okay.
Okay. So now you need to be watchful here. One full turn of a circle, we call it in degrees, that is 360 degrees, right? And this part is actually 0.28 of the radius. So one, if we are now we have been talking about the degrees. Now we'll talk about the radians. So one full turn is, in terms of radians, is 6.28 radians, right?
Okay.
Okay, so if we create it, one full turn in degrees and one full turn in the radians, we, we can we can take it as 360 degrees is equal to 6.28 radians. And another thing that we know is the complete circumference that we have just made a base here, one this one here, one complete circumference that equals one full turn, that is also equal to the 2 pi. We can call it equal to 2 pi. Are we good in here?
Yes.
Okay, so we can make two as a two equations here. 2 pi is equal to 360 and 2 pi is equals 6.28 radians. So the task is, the thing that we are looking for is, what is 1 radian equals in numerical value? What is the numerical value of 1 radian? That's our target. That's we're gonna solve for.
Okay.
Okay, so that is 2 pi radians. 2 pi radians, the complete revolution, equals 360. And if we want to work on it, we can divide the thing here with 2, that equals pi radians equals 180. Are we good here?
Yes.
So 180. So we're gonna talk about the semicircle here, that is 180 degree, that equals pi radians. In terms of, if we talk about the degrees, it is 180, and if we talk about the radians, it is pi radians. Are we good here?
Okay. Yes.
Okay, so if we need to remember this, pi radians equal to 180, or you can call it 2 pi radians equal 360 degrees. So
Okay.
So we were looking for 1 radian. So if we work more on it, we need to divide it by the pi as well. And pi value is 3.14. And if we cut it out, the 1 radian becomes 180 by pi. That comes out to be almost 57 degrees. So that's the way we converted from radians to degrees. So 1 radian equals 57 degrees. If you have a calculator with you, you can divide 180 by 3.14. You would get the answer, that is 57.29.
Okay.
0.29 to be exact, or we can round it off to 30. Okay. So that's the first result we have got. The next thing is the interconversion. So for that part, let's recall the equation here. That is,
Okay.
if pi radian is equal to 180, this one, the right side is in degrees and the right side is in radians. So this equation will give us the interconversion facility.
Okay.
So for now, I will go to the results first, and then I will try to prove it, so that you can remember it. So if we want to convert degrees to radians, we need to multiply it by pi by 180. Like the degrees, the whatever the question we have got, if we want to convert it into the radians, we need to multiply it with pi by 180. So we would get the answer in radians. And the other thing is, if we already have the radians, like we have radians, and we want to convert it into the degrees, we need to apply it, we need to multiply it with the reverse of it, that is 180 by pi. Okay.
Okay.
Okay, so these two results are important that we need to remember all the time. Elias, have you made up a formula sheet, like the basic formulas only?
Yeah.
Okay, that is always a good idea. So you need to have a 2 or 3 page sheet with you, and whenever we get the final results, you need to just put it into your formula sheet. And if you have an exam or something like that, you just need to revise your formulas, and so that you can work easily on it. So if we have a angle here, let's say 30 degrees, and we want to know what would be the value in the radians. So we need to multiply it by pi by 180. So if we do it like this, 30 multiplied by pi by 180, we cancel out this 3 with this. 3 ones are 3, 3, 6 are 80. So it becomes pi by 6. So you need to remember this one here. Okay.
Okay.
Now let's go for the 60, and we want to know about what would be the value of 60 degree in the radians, and we can go the other way as well. So this is the final graph that we have, that is let's make it bigger for you to see. So for the, we have this 30 degree, 45 degree, 60 degree, and 90 degree. And we want to know what would be the values. So let's start with the 0, and I'm just gonna increase the value here. So we have got 30 degrees in terms of degrees, and pi by 6 radians. I'm just gonna work once again to know that how did we get that. So we have 30 degrees, and we want to know its value in radians. So I have told you, if you want to do that, you just need to multiply it by pi by 180. You would get the answer in the radians. So this cancels out. 3 1 the 3 6. That is pi by 6 radians. Is this the correct answer here? Pi by 6.
Okay.
Okay. So now it's gonna be your turn. I want to convert 60 degrees into the radians. 60 degrees, and I want to convert it into the radians. What would I do?
So you do 60 times pi over 180, which gives
Exactly.
you 60 pi over 180. Then you can simplify it to be pi over 3.
Perfect. So let's see in the graph if it is the correct answer. Yes, it is pi by 3. And if I move it like this, for the 90, it's gonna be pi by 12. So you need to remember all these things, like not exactly memorize it, but with the usage, you would memorize all these things. So what would be the value for 180 degrees?
Pi.
Exactly. So let's do it once again here. Why it is like that? 180 degrees, and we multiply it by pi by 180 degrees, and it cancels out, and it is simply pi radians. That's the one way to go from degrees to radians. So in this way, we will get all the values. I will send you the map here for the all the functions like this.
Okay.
So anytime you want to look for it, it is, you can start it with the first quadrant of the Cartesian plane, like 0 to 90. That is 2 pi is equal to 360, pi by 6, pi by 4, pi by 3, and pi by 2. And then you can increase it. Um, or you can go to your calculator. The interconversion is also there. But for the if the part is concerned for your, can you see this part? I think I need to share it. Let me share the screen here. Hmm. Ah, so it says here, the first part, convert each degree measure to exact radians. So can you convert 30 degree into the radians?
Yeah.
Yeah, if you multiply it by pi over 180, you can convert it. And the same way like this. So I would say start it from 30, go to the 90, and then we will go with the B and C. I will let you know once we have completed this part. And now we will go for the vice versa. Let's see, we have mm, the other way around. So just in case we want to convert the radians into the degrees, what would we do? Mm, Elias, do you remember what would be the value for the 30 degrees into the radians?
1 or pi over 6.
Yes, it is pi over 6. So this time we need to multiply it by 180 by pi. That is, if we cancel out, simplify it, that is 30 degree. So you can put any value here. For the 90 degree, it is pi by 2. So we put it here, 1 and 2 pi, and it becomes 90 degrees. So if we need to do a little exercise, I will send you some exercise questions with the answers so that you can double check it.
Okay.
Mm, okay. So you can start working with for the other angles. For today, I want you to convert only 5 angles: 0, 90, 80, 180, 270, and again 360. Can you convert these degrees into the radians? 4 angles.
Yeah.
Yeah, so you can use your paper and just send me once we are done the second part of the assignment as well.
Okay. Okay, I'm done. Hello? Hello?
Alia, can you wait for 1 minute?
Oh, yes.
Hi, Elias.
Hey.
Okay. This the question that might arise in your mind is how to memorize this interconversion fraction. So the thing is, pi radian, are you do you really believe it that 180 degrees equals pi radians?
Yes.
Okay, so if we multiply the both sides, that becomes 2 pi multiplied by 2, it becomes 2 pi radians, means full turn, equals 360, right?
Yes.
Okay. So we need to, if just in case you forget this interconversion, or you might be having you make become double-minded if it is correct or not. So you need to visualize this thing. One semicircle equals 180 degrees and pi radian. So these two things become equal to each other. And now we want to convert these things. So what do you do is divide it by 180 and 180. So this becomes 1 degree, and this becomes pi by 1 over 80 radians. And now you want to convert, let's say you want to convert 30 degrees. So you multiply 1 degree with the 30 degrees and 30 degree here. So it becomes 30 degree, and this is the same formula that I told you, that becomes pi by 6 radians, right? So now
Okay.
you know how you got this fraction here. And if you want to go to the reverse side, again, you need to write the thing here, pi radians equal 180 degree, but this time you want to convert radians to degrees. So you need to make 1 radian here. So you divide the radians here by pi and the pi. This becomes 1 radian, that equals 180 by pi. And you want to convert, let's say, pi by 6. So you need to write pi by 6 on the both sides, and you solve it like this. 6 1 the 6 6 threes and 30. So pi by and you multiply it, pi by 6 radians. equals 30 degrees. Are we good here?
Yes.
Okay. So only one thing that I'm stressing you is you just need to remember this form of the equation, or 2 pi radians equals 360. It is your choice.
Okay.
Okay. So let's share your assignment part. That is this. So, Elias, can you reverse these values pi by 6 into the degrees by using the formula?
Okay.
Okay. So, I would say just skip these two parts here for now. And once we are done with the 360-degree, I will let you know. And the same thing, you by using the calculator, you can interconvert these things. So I want you to reverse all those information, Mm, like like this circle here. So like you need to remember these things. If I ask you what is pi by 3, so you can tell me that is 60 degrees, right? So I want you to reconvert all that you have converted into the radians. So let's say 0 radian, what do you call it, pi by 2 radians into the degrees, and pi radians into the degrees, and 3 pi by 2 radians into the degrees by using the formula.
Okay.
Okay. So I'm going to give you a few minutes so that you can do it. You can send the assignment to the consultant, educational consultant, and I will check for it.